Our theory is to enjoy life, but our practice is against it. Theoretical learning is what the knowledge is about, and practical application is how the knowledge learned can be implemented in certain real life situations. Like scalar product, which is also known as the dot product, and what is that? A dot B is AB cos theta, the expression of the two vectors when multiplied by the means of dot product, you will get this resultant, and if a vector is multiplied by itself, the dot product will be this. But if I say that this is the force vector and this is the displacement vector, can you find the angle between the two? Step 1 will be to calculate the dot product of force and displacement vectors. Step 2 will be to find out the magnitude of both the vectors. Finally, in the step 3, you will be substituting the value of f dot d and the magnitudes of f and d to find out cos theta, and theta will be nothing but cos inverse of the value that you are getting. So you all know about the force of friction and that it opposes relative motion. So I have a cart here, concentrate on its wheels. So I mark a point of contact on one of the wheels. This is the bindi. And see, this is the point of contact. Now observe the motion of this point of contact with respect to the surface. Now if I say that this cart comes to a skidding stop. Now what is skidding motion? Skidding motion is like this. This is not rolling. There is difference between skidding and rolling. Skidding is simply sliding on the surface with no rolling motion. It's like this. Whereas rolling is this. So if this cart comes to a skidding stop after some time, so what will be the direction of the force of friction? It will oppose this relative motion. The displacement is in which direction? The displacement is in this direction, and the force of friction will oppose this relative motion of this point of contact with respect to the ground. So it will be in the direction exactly anti-parallel to the direction of displacement. So if displacement is in this direction, the frictional force will be in this direction, exactly anti-parallel to the direction of displacement. So if the displacement was 10 meters before this cart came to a skidding stop, and the force of friction because of the ground on the wheels on the cart was 200 newtons, can you find out the work done by the ground on this cart or the cycle? So you know that work done is nothing but the dot product of force and displacement. फोर्स का भी मैग्नीट्यूड आपको पता है एंड डिस्प्लेसमेंट का भी, एंड यू नो द फैक्ट दैट द फोर्स एंड डिस्प्लेसमेंट, द एंगल बिटवीन दीज टू वेक्टर्स इज पाई 180 degrees. So you simply put the values of all the parameters and you will be getting the work done by the ground on the object. Now you know that the object, which is cycle or the cart in the present case, it is undergoing some displacement. Displacement is finite. Some finite amount of force is also acting, and the angle between the frictional force and the displacement vector is not pi by 2. It's not 90 degree, it's 180 degrees. So all three conditions are satisfied so that the work done by the rod on this object is non-zero. So that's why you are getting the value, and this work done comes out to be negative work done. As I told you, work done can be positive, negative or zero. Now if this is clear, if I ask you how much work does the cycle do on this surface or on the road, how much work does this cart do on this surface, you have to recall Newton's third law for this. You know that the force of friction because of the ground on the cycle is 200 newtons. You know that forces always occur in pair, an equal but opposite in direction. An equal and opposite amount of force will be acting because of this cycle or the cart on the surface. So the magnitude will be this, but the direction will be exactly anti-parallel. 200 newtons, but in the anti-parallel direction, exactly the opposite direction. So force exerted by this cart on the surface will be also 200 newtons. Now what you need for work done? Force and displacement. You know the force, but is the surface undergoing any displacement because of this force? This cart is applying 200 Newton force, no doubt, but is this force able to displace this surface? No, clearly no. So if this surface is not undergoing displacement despite of this force, we say that work done by this cart on the surface will be zero. So an important statement that I would like to make over here is that if this is object A and this is object B, though the force on object A because of B is equal and opposite to the force on B because of A, however, the work done by A on B need not necessarily be equal to the work done by B on A. Theory teaches about the experiences of the others. Work done is zero if displacement is zero, while by practically experiencing a particular task, you can build your own experiences. If I am pressing hard against this wall will undergo no displacement. So practical application along with theory gives us a clear explanation about the facts. Best part of practical application is whatever you learn through the practical way will remain with you for a longer period of time. Philosophically, the knowledge is intangible. It cannot be touched. It's there. You cannot touch it, but practical application makes it tangible by applying those skills in practice. For instance, you learnt in my previous video whether there is some relation between this work and energy. Work done is nothing but that is equal to the change in the kinetic energies of the body. So let us try to employ this theory into practice. I take an example of a real life situation. You must have observed a raindrop falling under the influence of gravity. There's another force that is acting, the air drag, in the exactly opposite direction to the direction of gravity. You have a gravitational force and the resistive force, the air drag. Now if this drop of water is of 1 grams and it falls from a height of 1 kilometers and it hits the ground with a velocity of 50 meters per second. Can you calculate the work done by the gravitational force on this drop? This is an easy problem. You know that the work done is force dot displacement. The force, gravitational force in the present case, because you have to calculate the work done by the gravitational force. Its direction is also downwards and the displacement of the drop is also in the downwards direction, so that the angle between the force and displacement is 0. Cos 0 is 1. So what are you left with? F dot d, Fd cos theta, Fd cos 0. So magnitude of force into magnitude of displacement is all you need to find. So what is the magnitude of force? Force is nothing but mass into acceleration. Mass of the drop is known and acceleration will be the acceleration due to gravity, which is approximately 9.8 meters per second square, and you can take 10 meters per second square for this problem, and this has to be multiplied with the displacement, and you know that this is nothing but the height from which this drop falls, and this is 1 kilometer. So simply put the values and find the answer. So next part can be slightly tricky. If I ask you to calculate the work done by the resistive force, the air drag, what will be that? So for this you have to employ your work energy theorem, which says that the change in kinetic energy of a particle is equal to the work done by the net force. Net force. So work done by gravitational force has already been calculated by you. Another work is by the resistive force. So change in kinetic energy of this drop will be equal to the work done by the net force. And what is the net force? the gravitational force and the air drag and the resistive force acting in exactly the opposite direction. So work done by the gravitational force, work done is scalar, work done by the gravitational force, you got it, positive, plus the work done by the resistive force that needs to be calculated in the present situation will be equal to the change in kinetic energy. So let us first calculate the change in kinetic energy. So initially, if you consider this raindrop to be at rest, the initial speed will be 0. That means that initial kinetic energy is also 0. So final kinetic energy will be half m final speed square. Mass is also known, and you know the magnitude of velocity with which this drop hits the ground, which is 50 meters per second. Put the values and calculate the final kinetic energy. So this value, the change in kinetic energy, will be nothing but the final kinetic energy, because the initial kinetic energy is 0. So this will be equal to the work done by the gravitational force plus the work done by the resistive force. You have all the values now, calculate your answer. So now you see that this work done by the resistive force is negative. Now let me give you a last example. You have a bullet of say 50 grams and this is fired with a velocity of 200 meters per second. This bullet hits a target which is of 2 centimeter thickness. This bullet, ये अंदर नहीं रह गई target के, this bullet emerges out of the target with obviously reduced kinetic energy, and the kinetic energy is now 10% of the initial kinetic energy. So can you calculate the emergent speed of this bullet? Means that you have to calculate the final speed of the bullet. So in the problem, the mass of the bullet is also given and the speed with which it is fired is also given. So you can easily calculate the initial kinetic energy. You get a value and the final kinetic energy. जो ये कह रहे हैं final kinetic energy when this bullet emerges out of the target, it is 10% of this initial kinetic energy. So 10% of the value, 10% of the initial kinetic energy value will be the final kinetic energy that you are getting. Now you have the value of final kinetic energy as well, and this is nothing but half m final speed ka square, and final speed is what I asked you to calculate. Mass of the bullet is known, final kinetic energy is known, then where's the problem? You can easily calculate the final speed. So from these examples, it's crystal clear that practical knowledge guarantees that you are actually able to do something instead of simply knowing how to do it. Theory is knowledge and practice is the ability. So I conclude my video with a famous quote which goes like this: in theory, there is no difference between theory and practice, but in practice, there is.